Okay, so now we're just going to finish centroids right now, and we're going to teach you a little algebraic shortcut. So we can definitely find centroids by finding all three medians, so connecting the midpoints and the opposite angles, and that's the balancing point, the center of mass. That's what's so great about centroid. We can also just do it purely algebraically. In this case, let's see, D is the coordinates -8, +4. E is the coordinates 10, 7, and F is the coordinates 4, -2. Now, what I like to say, centroids is the balancing point of triangles. What's the balancing point of a segment? Well, that'd be the midpoint. If you have a segment and you want to balance the segment, the midpoint is the balancing point. So it's the same thing for triangles, except we have 3 points instead of 2 points. So to find the centroid, you just take all the x's, you add them together, and divide by 3. Same thing for the y's. So this is why it looks almost the same exact as the midpoint formula. It's essentially the same concept, except the triangle is a little bit more complicated. It has 3 points, so it has 3 parts, rather where this midpoint just has 2 things. All right, so you're just gonna add up all the x coordinates. We have -8 plus 10 plus 4 divided by 3. And then we're gonna have 4 plus 7 minus 2 divided by 3. And then you're just gonna, what's -8 plus 10 plus 4? It's gonna be 6/3. And then we're gonna get 9/3. So the balancing point is at 2, 3. So all I have to do is go ahead and graph 2, 3. That's the balancing point. I'll call that P. So if I took a pair of scissors and cut this triangle outside of my iPad, that'd be the balancing point. I'd put my finger there, boom, balanced. I don't recommend you doing that. Why? You would destroy your iPad. You wouldn't be able to do any more of these fun guided notes or any more e-learning. All right, but that's how you do it algebraically. So we have it where we did it physically on an actual triangle. We had it where we did it coordinate geometry, and then we did it algebraically. Look at all these methods, all these things we have in our tool belt. So pretty cool stuff right there. All right, and then if I really wanted to, which I guess I will, is we could quickly draw the medians. Look how these points kind of, every side kind of has like an ugly midpoint. We're not necessarily sure where it's going at. Some of these seem to be in between points, or maybe sometimes they're on it. But those would be the 3 medians. All right, and then just to kind of tie up all the loose ends, we have all these true ratios. All right, so let me think about how I want to do this. We have this right here. We're going to be using these in the next video. And we have this length here. All right. Now, just to start it off, I guess. Remember, this is double that, so I'm going to call this 2, this 1. But it's actually 2/3 of the whole length and 1/3 the whole length. This thing's the whole length. So A to P, vertex to centroid, is 2/3 the whole length. Centroid to midpoint is 1/3 of the whole length. All right, and that's basically what we have right here. We have all these ratios. They can kind of seem overwhelming, but in the next video, I'm really going to boil it down, make it nice, slick, simple. All right. Is there anything else I want to say? Really, if you can just remember that. Let me clear this up a little bit. You can just say from there to, this segment to that segment, you're either timesing by 2 or dividing by 2. All right. Or you could say this thing's 2/3 the whole length, or that thing's 1/3 of the whole length. And then you just have the whole length right there. All right, so that's a quick summary, but as we progress to the next video, or excuse me, the next day of guided notes, we'll talk about this again in tomorrow's guided notes. It will make much more sense.